Unit 6, Video 7, practice with the heating curve. Okay, so in here we've got a problem on the board that's going to require us to calculate the heat to change 50 grams of lead from 25 degrees Celsius to 500 degrees Celsius. Now notice this isn't just specific heat and this isn't just phase change. Okay, because if we look at 25 degrees Celsius, we come over here to our data table. At 25 degrees Celsius, okay, well, the melting point is 327.5, and the boiling point is 1749. So at 25 degrees Celsius, we have not left the solid phase, so we are still in the solid state of matter. Okay, at 500 degrees Celsius, well, if my melting point is 327.5 degrees Celsius, at 500, I've entered the liquid stage. Okay, so if we look at our graph over here, we need to graph out the heating curve. So how much energy we need to put in to heat it and phase change. Okay, well, we're going to start at 25. So let's say starting at 25 is right here. Okay, we're going to heat it to its melting point. Its melting point is 327, so we're going to go somewhere right in between. So we're going to say it's right here. So we're going to heat till we get to there. Okay, and then when we get here, we're phase changing because we're melting. Okay, so heat of fusion is occurring right here. And then we say we're going to heat it to 500. So once we have completely melted, so we've gone from a solid to molten lead, we're going to then heat it to 500. Okay, so notice that we've got three parts to this, this problem. This right here, I'm changing temperature. So I'm changing temperature is going to require me to use the specific heat calculation or the heat capacity. Okay, so here it's going to be the Q equals my C times my N times my delta T. Okay, now I could use Q equals SM delta T if I wanted to keep it in mass. It really doesn't matter, you just need to keep it all the same. Okay, so we've got our calculation for here, so we'll say this is for problem 1. Okay, after we've then heated it to a certain temperature, we're phase changing. So if we're phase changing here, we're going to use our phase change equation, which we're melting. We're going from a solid to a liquid, so we're going to use our Q of fusion, which is going to be the number of moles times our delta H of fusion. Okay, now once we phase change, we're then heating our liquid metal. Okay, and we're heating our liquid metal till we reach 500 degrees. So we're going from a temperature of 327.5 to 500. So we're changing temperature. So this is going to be Q equals my C times my N times my delta T. Okay, because we're changing temperature again. Okay, so this is going to be my first equation, my second, and my third. So let's break it down kind of equation by equation or problem by problem. So the first thing we need to do is we need to find how much heat is required to raise the temperature from my starting point, which was 25, to 327. Now look, we're not going to 500 initially. We're stopping at 327 because we've got a phase change. Okay, so here we're going to have Q equals C times N times delta T, and we're going here from 25 degrees Celsius to 327.5 degrees Celsius. So I should put 2 here. Okay, so let's go through and do the problem for this. So the Q for this, and we'll call this our Q1 since it's our first heat. We need to find the heat capacity. We're in the solid phase. So if we're in the solid phase, we're going to use the heat capacity for the solid. So I'm going to do my calculations in moles. If you would like to do yours in grams, then you're going to use the specific heat. I'm going to use heat capacity. So we're going to say Q equals 26.5 joules over moles degrees Celsius. Okay, we're going to times it by our number of moles. Okay, well, I gave you the mass, so we can go ahead and convert this into moles. So if we convert this into moles real fast, we're going to take our 50 grams. Okay, we're going to get the molar mass off the periodic table, which is going to be 207.20 is to 1 mole. If you punch all that out, you're going to get 0.241 mole. So this is what we're going to be using as our moles throughout this problem. Okay, so we're going to multiply it by 0.241 mole. And then our last step is we need to multiply it by the change in temperature. Where our change in temperature is temperature final minus temperature initial. So our final is 327, our initial was 25. So we're going to take 327.5 and we're going to subtract it from 25 degrees Celsius. Okay, now we can punch all this into our calculator and we can get our Q. Our Q value is going to be 1,930 joules, which let's deal with things in kilojoules. It's going to make our life a little bit easier. So we're going to say this is 1.93 kilojoules for our Q1. Okay, now let's go in and let's do our second step. So our second step, we've now done this part here, so now we're here, so we're phase changing. So we need to do the calculation to phase change. So we're going to use the Q of fusion, so we're going to use our delta H of fusion. So the Q of fusion, so we need to find the heat to melt. We're going to have our number of moles times our delta H of fusion. Okay, well we know our number of moles. Our number of moles is 0.241. Our delta H of fusion, we're going to get off of our chart over here. We're phase changing, so we're going to use the delta H of fusion, which is 4.77 kilojoules per mole. Okay, moles will cancel, you'll be left in kilojoules. If you multiply these out together to find your Q of fusion, you're going to get 1,150 joules, which we're going to keep it in kilojoules to make our life a little bit easier. So if we keep it in kilojoules, we're going to get 1.15 kilojoules. And this is going to be our Q2. Okay, now the last step we've done, we've heated to the liquid, or we've heated to the boiling point, to the melting point. Now we have phase change, so now we're all in a liquid and we're going to heat that liquid. So if we heat that liquid, we're going to use our heat capacity for liquid because we're no longer in the solid state anymore. We've now entered the liquid state. So we're going to have our Q equals our N times our C times our delta T. Okay, but our heat capacity now is no longer going to be for the solid. It's going to be for the liquid because we've entered the liquid state. Okay, so let's punch all of this in. Okay, we know our N value. It's still going to be the same. So we're going to have 0.241 moles. Okay, times our heat capacity for the liquid. Heat capacity for the liquid is 29.0 joules mole degrees Celsius. Okay, and our last step is we need to find the change in temperature. Well, the change in temperature for our last step is going from where we melted, which was 327.5, to our final temperature, which our final temperature was 500. So we remember final minus initial. So this is going to be 500 minus 327.5. Okay, so if we punch all of that into the calculator, we'll get that the heat required to change the temperature will be 1,210 joules, which if we convert that to kilojoules, we're going to get 1.21 kilojoules. Okay, now we've got three answers. But here, we want to know calculating the heat. So this is the total heat required to raise it from the solid to the liquid. So it's going to be Q1 plus Q2 plus Q3. Okay, well we have all of that. We went through each one and calculated it. So we're going to take our Q1, which is 1.93 kilojoules, and we're going to add it to our Q2, which is 1.15 kilojoules. And then we're going to add that to our Q3, which is 1.21 kilojoules. Okay, you need to make sure these units are all matching. It's very important when we're doing this. If we were to add all of this up, we would get that the Q total would be 4.29